Okay, how to make a tessellation. The first thing I'm going to do is I'm going to draw a line on just one side, and I'm going to go from one end to the other. My line can't be too sharp. It needs to have some flows in it. I can do some points, but I just don't want everything to be too close together because I'll make it too hard to cut out. So there's my line. Now what I need to do is I need to cut very, very carefully on the line that I've created. So I'm going to take my time and cut very carefully. And one technique that I bet Mrs. Hubbs has taught you is that you can turn your paper as you're cutting to get it on the line and to get it just right. So there's my point. And then I have a curve. And I can just do any shapes that I like when I draw my line. Taking my time to cut it. There. Then what I'm going to do is I'm going to make sure that I have the piece in the right location, just the way I cut it out. And then what I need to do is I need to take the part that I cut out and slide it to the opposite side of where I made the cut. I'm going to tape it on, and I'm going to use small pieces of tape because large pieces of tape are actually harder to manage. So I'm going to put two smaller pieces of tape, one on each side, so that I can join my piece. And I don't want any tape sticking over. That's why I use small pieces of tape. Okay, so my tessellation is almost done. I'm halfway there. So now what I want to do is I'm going to draw another line, but now I'm going to work on either one of these sides. So I think I'm going to start on this side. I'm going to make sure that there's my end of this side. It's not actually over here, because remember that's where my tessellation piece went out, but I am going to go from edge to edge again. So this time I think I'm going to put in more zigzags. And again, I'm going to take my time and I'm going to have to cut it. Turning my piece, cutting. I have to be really careful I don't cut through to the other edge. There. Okay, now it flipped over, so I'm going to make sure that it fits back in, sort of like a puzzle piece, before I take it and I slide it to the opposite side again. And using small pieces of tape, making sure it's lined up edge to edge, I am going to tape it on. And there is my tessellation piece.
Okay, I'm a math teacher and I'm just going to share one of my projects with you really quick. It's kind of like an art-math crossover project, some Escher-esque tessellations. So we're going to start with an equilateral triangle because that's a really easy shape to tessellate, but we kind of like make each side really funky so that it doesn't look like a triangle anymore. It's going to be a crazy shape, but it's still going to tessellate, and then it turns out to be a really cool project. So we're going to start with my favorite medium of all art supplies, construction paper. Just construction paper and like pencil and protractor. And the third part, I'll share some finished products from this year because we just finished ours. So I hope you enjoy it. Okay.
Alright, so we're going to start out with a equilateral triangle here. Whether your shape tessellates accurately or not totally depends on this being right. So make sure you have exactly 60-degree angles on all three corners. Probably measure them all a couple times before you move on to the next step. Alright, the next step is to funkify one of the sides of your triangle. So I just drew that thing. You can basically put anything you want there. Just start at one end point and end at the other one. Now, you see I'm cutting this out. The principle behind this tessellating is that the same exact side, what I just changed on that one, needs to rotate and also be on another side. So since we can't exactly do that accurately freehand, what we're going to do is cut out our shape, then trace it onto another piece of construction paper. Once we've done this, we'll be able to use the one that's, able to move around in our hands, and then rotate the side that we just changed wherever we want to and trace it, and that way it'll be the exact same duplicate side, only in a different part of our triangle. And hold down the endpoint and rotate it over. So now it matches onto a different side. Notice that the two corners of the triangle, like those, yes, I'm pointing at them, and then the line that we have kind of serve as a guideline. Make sure that the corners match, the line matches, so it's exactly where it should be, and then all you have to do is just trace that funky side onto a different part of the triangle. So now we have the exact same deformed side, but it's on two different parts. It's just rotated 60 degrees. Which leaves us with one side left to make crazy. So the other two sides fit into each other. This side needs to fit into itself, so the first thing you've got to do is find the midpoint, which I've just done, and then just transform half of it. You can do anything you want. I've done that for some reason. And again, we need to rotate that half of a side that I just made onto the leftover half of the side. So in order to do this accurately, you're going to do the same step. You're going to cut out your shape and trace it back onto another piece of construction paper. So as you can see, we've got our shape almost finished. It's just got half of a straight side that needs to be fixed. Okay, pretty much the last step we need to do is get the side that we just drew, that half of the side, to rotate 180 degrees so it matches up with the half a side that is still normal. So again, match up the corners, match up the midpoint, everything should be the same. So the part that goes in to our shape on the left now goes out, so that now this side will fit into itself because the right side fits into the left and the left side fits into the right. So now you've drawn your completed shape. Take a coffee break and cut it out, and this will be a completely transformed shape that looks nothing really like a triangle, which it started as, but since we didn't mess with any of the principles that make the triangle tessellate, it's going to be a crazy shape that still tessellates, and that's going to allow us to turn this into a pretty cool art project. At this point, you're done with all of the math or geometry that you would use in the subject, and you get to start drawing and coloring. At this point, you can also start looking at your shape and brainstorming, because for the art part of the thing, I tell my kids to look at this kind of like when you look at clouds and start thinking, what do you see in your shape? Because you're going to try to implement some kind of art design into it. Alright, so there's our final shape. Doesn't look like anything, but yeah, it tessellates. So the next part of the project that I have everybody do is get a blank piece of paper and use this as a stencil to trace it. So start in the center, because if it gets off at all, if it wasn't perfect, that way all the parts where it gets bad are towards the edges. And then just like after you've traced it, rotate it so it fits into itself, and then trace it again, and so on until you've covered up your entire page. So you can see that this shape does in fact end up tessellating because we followed all the steps correctly. Now there's one more thing that makes this project cool, and that is the art section of it. And what we do is I put out the shape and I say, imagine what you see in it. Now for mine, I saw like this little devil guy with the goat feet and wing on the back and horns. So I do that on a separate sheet of paper, draw it, make sure it still tessellates, everything works out, cool. And basically all that you have left to do is, on that other sheet of paper I showed where it's stenciled out over the same, like the whole piece of paper, just implement your design into each one of those spaces, and it ends up looking like that crazy little devil guy, but he tessellates and fits into himself all over the place, so you have like 10 of them on the same page. It ends up looking pretty neat. So here are some ones from my 6th grade class this year.
If you are a student, you should show your teacher this, because then like they'll do the project maybe, and it's fun, and it takes you out of regular boring like answering questions in math. Or if you're a teacher, you should show it because it's awesome. And if you are, if you're a principal, you should hire me because I teach in Florida.
Alteration by rotation of an equilateral triangle, tessellation. Now that's a title. So we're going to make this tessellation in SketchUp. So open SketchUp, and we need to set up our canvas by deselecting axis. Using the large tool set is a little easier. Under camera, we want a parallel projection and a top view. And get rid of the person icon. So select the polygon tool, which is a triangle shaped tool. And the default will be a hexagon, so type in 3S, and you can see it at the bottom right hand corner. 3S will give us an equilateral triangle. If you make a mistake, you can always just hit Command Z or Control Z for a PC. Zooming in, I can click Z and use the keypad, the mouse pad, and H will pan. If I hit escape, it goes back to the original tool. So I want to alter this side of the triangle and then rotate it. So I can either use a line tool or the arc tool or a combination of both. So I'll start off with the arc tool. I need to do 3 clicks, one to start on one endpoint, and then another click to find the other endpoint, and then a third click to get the amount of arc that I want. So I'm going to play with this coming inside the triangle and then outside, and I'll end with the line tool. So now I'm going to select this new design that I just created, and I'm going to hold the Option key for Mac or Control for PC as I click all these arcs and segment. And then I'm going to use the rotation tool, hold the Option key or the Control key to toggle it. Options for Mac, controls for PC. Choose the center of rotation, one click, and then the second click an endpoint, and rotate it. And I could snap it into the other vertex, or I can type in 60 degrees. It'll pop up in the dialog box at the bottom right here. 60 is because it's an equilateral triangle, and all the interior angles are 60 degrees. Okay, so there we go for that side. Now, I don't have to change the bottom, but if I do, I want to make it interesting, I'm going to go from the midpoint and create a design here from the midpoint to the end point. And I can use the arc tool again, and then maybe the line tool. And the idea here is I'm going to rotate this new design from the midpoint to the end point 180 degrees, so it matches up with the right side. So I need to deselect the highlighted area I created and use the Option for Mac or Control for PC and select the new arcs and sides that lines that I've created. And now I'm going to use the Rotate tool while holding the toggle key, Option or Control, and rotate it 180 degrees. Here I can also type in 180. I want to make sure that there's no overlapping sections in the design that I've created. If there are, I need to redo this so I don't get any overlaps. If it overlaps, it won't work. Now use the eraser tool, it's a big pink eraser, and erase the original equilateral triangle. What's likely going to happen is your shape will deselect. It will no longer be filled in. So we have to retrace part of it. So usually it doesn't matter which part. I'm just going to use the line here and, oh, there it is. Sometimes you got to do a little bit more than this. now I'm going to design my shape. It kind of looks like a dog. So make sure you periodically save. Go up to File, Save As, and put it somewhere and repeat. So let me just show you that this will in fact tessellate. So if I use my rotate tool and hit the toggle button, you'll see that it will rotate on both sides. It will tessellate. But for now I just want to copy this using the copy tool. It's got the 4 arrows on there. Hold down your toggle, bring it over. At this point I'm going to rotate the second shape 180 degrees, and you'll see that this will fit perfectly on the bottom of the original shape. So grab it, you don't need to toggle it when you're moving it, and grab a corner that corresponds to another vertex and snap it in there. Snap. Now's the time where we color and have fun with this. Choose your color scheme, and once you're finished, go ahead and select the entire shape, and then we're going to make a component of this so it locks in everything so you don't make a mistake later on in your tessellation and have to redo a whole bunch of stuff. So I just created a component. You can see the whole shape is selected. Now I'm going to hit the rotate tool, toggle it, and just play with this. There are many ways that you can tessellate this. You could start off with going around the same center, and we started off originally with a triangle, so in order to make 360 degrees with a equilateral triangle, you have to go around, copy this around 6 times. Well, same thing here. You need 6 of these figures to tessellate the entire piece. Now I'm just selecting pieces and continuing to copy and rotate this around the original center. And if it starts getting tricky on the snapping, you can always just type in the amount of degrees that you need. So be careful about the overlaps and gaps. As I zoom in here, you see I've got this very tight and no gaps or overlaps. Once you've done enough, you can zoom in and try to fit the screen so you don't have any sections, unfilled sections on the edges. And then you can, now you're ready to save this now and export it as a 2D graphic. And basically that's just an image. And you can make it a PNG file or a JPEG file. Find a place to put it on your computer. Hopefully you've got a geometry file in there somewhere, and then you can put this in a Google document and share it. So there we go. I hope you found this video tutorial useful. See you next time.
A cube has 9 planes of symmetry. These cut the cube into 48 pyramid-shaped chambers, each of which is a reflection of the others. In fact, if we make one of these chambers out of mirrors, we can recreate the entire cube just by using one small triangle, which is reflected 47 times on these mirrored surfaces. This cube frame, for example, is composed of only 1/2 of a cylinder, reflected again and again in this kaleidoscope. By moving this cylinder around, we can create an endless variety of polyhedra and other 3D forms. We can put other shapes into our kaleidoscope as well, to get all kinds of fun and interesting effects. This strange and beautiful world is all made from 3 mirrors, carefully arranged in alignment with the planes of symmetry of a simple cube. Now let's imagine we could go into the kaleidoscope ourselves. I'm Mike Naylor, and this is the Human Kaleidoscope, part of the Naked Geometry project. Find out how you can be a part at nakedgeometry.com.